To this point, we have talked about the beginning of the West Coast mountains, the beginning of the East Coast mountains. We've talked about sea level rises and sea level falls. Up until this point, we've made it just about to 450 million years ago. So we are here on our timeline. Now we are going to move in to the second portion of the Paleozoic era. And it'll move a little bit faster than the first one, don't you worry. All right, so going into the late Paleozoic, still there are a series of transgressions, sea level rise, and regressions, sea level fall, just like there were in the early Paleozoic. Now, notice that during the late Devonian, the sea level was fairly high. This was at the end of a sea level transgression. And when the sea level was fairly high, much of the Laurentia continent was covered with a shallow epicontinental sea. And during this time, a huge meteorite impact event happened. So we call it the Alamo impact event. It happened during the late Devonian. It was the largest, or one of the largest known meteorite impacts that has ever occurred, and it hit what is now southeastern Nevada. It was a cosmic catastrophe. The crater was about 100 to 150 kilometers in diameter. There was more than 1,000 cubic kilometers of pulverized rock and melted materials just ejected out from the crater. This created a huge tsunami that we've seen evidence of far away from this impact event. The object that created this huge crater, we think would have had to have been about 4 to 5 kilometers in diameter, traveling at 20 kilometers per second. Can you imagine 20 kilometers per second, that meteorite crashing into Earth, right? No wonder it caused such a huge explosion. Right? Now, this event occurred 367 million years ago. Between the two late Devonian glacial episodes, which we're going to discuss a little bit later, and their related mass extinctions, which we're going to discuss last week. So keep this in mind when we're talking about these glacial episodes and mass extinctions. All right, so we talked about how sea level was high in the Devonian. This was when the Alamo impact hit what is now the Western US, creating tsunamis and a huge amount of material ejected. Now we're going to move forward in time up until the Pennsylvanian era, and notice that around this time, sea level is rising during the Pennsylvanian and then falling during the Permian, right? So we've got another sequence of sea level rise and sea level fall. In the middle of the Eastern US, we find what we call cyclothems. Specifically, if you find them during the Pennsylvanian era, we call them Pennsylvanian cyclothems. And these are cyclic repetitions of sequences of marine and then non-marine strata. So marine rocks, then non-marine rocks, marine rocks, then non-marine rocks. And this was caused by sea level transgression rising and sea level regression falling. The global oscillation between sea level rise and sea level fall, we think was caused by an oscillation between warm periods and cold periods. We think this was due to just natural variations in orbital cycles of the Earth that are still happening today, but the frequency of them, or the time period of them, is very, very long, tens of thousands of years for these cycles to occur. Okay? Now, during a cold period, when the ice sheets grew in size, sea level lowered because that water was removed from the ocean and pushed up on land. Remember that ice age, or not the ice age, remember the glacier event that occurred on Gondwana. And then during warmer episodes, the meltwater that was held up on land returned back into the ocean and raised the sea level, right? So we have these sea level oscillations that cause shorelines to shift back and forth through time, producing the cyclothems. Now, cyclothems are really valuable because they contain coal beds that we can correlate over great distances. For example, those in the Appalachian region near us can be correlated to cyclothems all the way over in Western Kansas, right? So we can do correlation almost across a lot of our continent. Geologists recognize at least 50 cyclothems within a section of only about 750 meters thick, and they can extend for thousands of square kilometers. So these cyclothems and these coal beds are really, really helpful to help geologists correlate through space, understanding what was happening back in the Paleozoic. All